This video is the beginning of Unit 2. Now we're moving on to solving systems, which this is something that you did learn in Algebra 1. What we're going to focus on today is how do you solve systems by graphing only, okay? So the first thing is a system of equation is just two or more lines. So we want to look for where they intersect. So that's what we're going to be focusing on today. So if you can think back to Algebra 1, a lot of things can happen, okay? Most of the time what's going to happen is you're going to graph one line, graph the other line, and you're going to have intersecting lines. That's where you're going to have one answer. And your answer is going to be X, comma, Y. It's literally where they're going to intersect, okay? This is what happens a majority of the time. But there are two special cases. So then what could also happen is you could actually graph it, and it's the same line. And so this is something where they're the exact same line. So we call them coinciding or same lines. But the answer is it's infinitely many solutions because all of these little points on the line are on both lines. So every single point that's on one line is also on the other line. And then the last thing that could happen is you graph these two lines and they're never going to meet because we say that they're parallel. And so there are no solutions. So most of the time we're going to get an answer. We're going to figure out where they cross. And then sometimes you get these two special cases where they cross at every single point that's on the line or they never cross. Okay. So here are the steps that, and if you need to write these down, you can go ahead and pause the video. You're going to get both equations into slope-intercept form, which means we want them to look like this. We want them to say y equals so that we can find here is the slope again, and then B is your y-intercept. B for begin, move with your slope, so that they are ready for us to graph right away. So if they're both, sometimes they're already ready to graph, sometimes they're not. Once they're both ready, then you're going to graph both lines. And then the last thing that you're going to do is write down that intersection point if there is one. Sometimes it's infinitely many, sometimes it's no solution. So I'm going to do an example for you. I want you to notice that this one, they are both ready to graph because they have y equals and y equals. So they're both ready, so I don't have to do much work. So what I'm going to do is I'm going to graph the first line in red, and I'm going to start here. On the y-axis, I'm going to put a point at 3. So it's positive 3. So I'm going to count up 1, 2, 3, and put a point right there. Now I'm going to move with my slope, and my slope is just a negative in front of the x. So what that means is negative 1 over 1. This is how much I'm going to go down, and this is how much I'm going to go over to the right. So I'm going to go down 1 over 1, down 1 over 1. Now, in the last chapter, you only needed to put 3 points and then you could be done because you were just drawing one line. But now I very much recommend doing a ton of points because you're looking for the intersection point. So that's a little bit harder to find. So I'm going to put a bunch on here and then I'm going to try my best to connect them. Okay. So I'm going to graph one line, and now in the same problem on the same graph, I'm going to graph the second line. So I'm going to start here, but it's a negative 2. So I'm going to start on the y-axis at negative 2. Remember, you're always starting on the y. My slope is 3 over 2, positive. So I'm going to count up 1, 2, 3 over 2. And boom, I found it. So I only have to do one more before I connect it, okay? Do not just leave dots on the graph. You do have to connect it to make it a line. But then what you're going to do at the end is you're going to write down this point where they cross, which is at positive 2, positive 1. So this is the answer. So if you're solving the system by graphing, you need to graph both lines and write down the intersection. And that's it. The next problem I'm going to do for you is where they're not equal to y, and so you need to make them equal to y. So I'm going to focus on the first one. This is, again, something we did in the last chapter. If you have 2x plus 4y equaling 12. My goal is to get the y by itself. So I need to move this 2x to the other side. So it's a positive 2x. So the opposite would be to subtract it. It goes together, okay? And we've talked about this before. What's going to happen is I still have 4y equaling this minus 2x is kind of going to get squeezed in first, and the plus 12 is going to get pushed back. And that's because we wanted to say mx plus b, okay? Now, I want to get rid of the number in front of the y, which is 4. That's multiplication, so the opposite is division. So I'm going to divide by 4, divide by 4. Everything gets divided by 4. So y equals, now this negative 2 over 4 is negative a half, okay? If you put 0.5, that's going to be really hard to graph. Remember, slope is okay to be a fraction. And then 12 over 4 is positive 3. So now this line is ready for me to graph it. So I'm going to start at positive 3, and my slope is negative 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. And again, I'm going to put a bunch of here on here. I'm even going to go back to where I started and go the exact opposite way because I don't know where they're going to cross it. Okay. Now I'm going to look at the next one, and I still need to get this one y by itself. So I need to move this x to the other side. It's positive, so the opposite would be to subtract it. Okay, and remember, 2 and an x, one's a number, one's a variable. They cannot be combined. So it just kind of gets squeezed in front. Now this one I don't have to divide because y is already by itself, so that one was easier to get. This one means I'm going to start at 2, which is right here, and I'm going to go negative x. Down 1 over 1, down 1 over 1, down 1 over 1. But I'm getting farther from the line. So I'm going to go up 1 over 1, up 1 over 1. And it's going to actually meet right there. And so once you find it, you can stop and you can say the answer is this intersection right here, which is at negative 2 all the way up at positive 4. And there you go. So you're going to graph both, tell me where they cross. Graph both, tell me where they cross. The hard part about this whole thing is getting them ready to graph. And then you have to be good at graphing. Okay. What I'd like you to do is I'd like you to pause the video and try to get both of these to say y equals, and then I'll show you what they look like. You can check your work and check the graph. So go ahead and pause it now. Okay, I'm going to show you what this one looks like when you solve for y. So I have 2x minus 2y equals 4. So I take this. It's positive, so I'm going to subtract it over. So I have negative 2y. Be careful not to drop that negative sign. Minus 2x, and then the 4 gets pushed back. I'm going to divide by a negative 2. So this is where y equals a negative divided by a negative becomes a positive 1. 4 divided by negative 2 becomes negative 2. Now this one is ready to graph down at negative 2. But my slope is up 1 over 1. And I'm going to connect it. Now, if I get the other one by itself, notice this is a negative 1x. So the opposite is to add it over instead of subtract it. So I have y equals a positive 1x plus 6. There's no number in front of y, so that's all I had to do. So this one I'm going to start at 6. And I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And they're never going to meet. Notice my slopes are the exact same. So they are parallel. This one has no solution. So if you notice that they're the same line, you're going to say infinitely many solutions, meaning every point that's on one line is also on the other one, because you would get the same equation. These two equations would be the same. Okay, they're not the same, but they do have the same slope. So I know that they're parallel, which means there's no solution. Okay. Last type of question is sometimes we might ask you like to create an equation rather than graph it. Okay. So if I want you to make 3 different equations using this is one of them. Okay. I'm really testing you on, do you know stuff about their slope? Okay. So if I wanted to create an equation that was no solution, what that would mean is it would have to have the same slope. And what does this slope have? It has a slope of 3. So I need to make a new equation where it has the slope of 3. So I'm going to put 3x, but I'm just going to change this last number. I'm going to change it so that it's not a 6. If I want infinitely many solutions, that means they have to be the same line. So I'm literally going to write down the exact same thing that I see. They have to have the same line. Okay. Over here, they have to have the same slope. Okay. If they were to have only one solution, you literally can make anything you want. Positive slopes, negative slopes. I can make it -2 plus 1. It's going to cross it somewhere because nothing is the same. So over here, everything has to be the exact same. Over here, you just want the same slope. And then if you only want one solution, make it anything but the 3 and the 6. Okay. So at this time, if you need to, you can rewatch the video or you can start your homework, which is a worksheet on Solve by Graphing.